Ransomware is a vicious type of malware that cybercriminals use to block companies and individuals from accessing their business-critical files, databases, or entire computer systems until the victim pays a ransom. It's a form of cyber extortion that's growing quickly in scope and in impact. Opinions on the subject are abundant, so let's take a look at some key facts to understand the true cost and frequency of ransomware attacks. Every 11 seconds, a business will be attacked by ransomware by 2021. The average cost of ransomware attacks in 2020 are over $4.4 million. As cloud services become increasingly critical to more businesses' daily operations, ransomware attacks will follow to maximize profits. And new types of ransomware attacks arise on a regular basis, and it can be difficult to keep track of all of them. So here's a list of common types of ransomware attacks, with data exfiltration being the latest. So whether your data resides in your data center or in the cloud, it's vulnerable to ransomware and malware attacks. So this is happening all around us, and all of that data is being exposed. So I'm going to show you one type of an exposure. Once I have access to the file system, I'll show you what I can do by simply compromising a single application. It's pretty scary stuff because you'll no longer have access to your data. So to start, we need to protect against this. And that's not your only problem. What if they hack the user, or if they have access to the system and they simply write a few lines of code and take over your entire file system? Here are the top 4 baseline security practices that IT security teams are employing to defend against ransomware attacks. And here are the reasons why these security measures are failing. Security awareness training. Employees are being trained on a regular basis with simulation tools to learn how to recognize phishing emails and avoid clicking on suspicious links. But 1 or 2 employees out of hundreds could still make a mistake and succumb to phishing attacks. Then we have the different gateways. Organizations use email web security gateways in the perimeter to detect and block ransomware that are sent as email attachments or from suspicious websites. But these security gateways depend on signatures to detect and block ransomware. They generally cannot detect zero-day ransomware attacks for which no signatures exist. Then we have different types of scans for vulnerabilities. Organizations also scan all systems on a regular basis to detect any endpoints that are vulnerable to ransomware attacks, but they forget to patch all systems if they're not critical servers. So ransomware can gain a foothold on an employee's laptop and then laterally move to a critical server and do damage. Then we have DNS security. This can also be deployed to monitor backhaul traffic between an infected endpoint and a known CNC server. But DNS security also depends on having domain names of known CNS servers. With domain generation algorithms, and hackers can rapidly change domain names of CNC servers and thus bypass the DNS security measures. Therefore, most security products like next generation firewalls, email or web gateways, endpoint protection platforms, and endpoint detection and response claim to detect malware in the earlier phases of the attack. So we can't stop all of these, right? No matter what perimeter security protection is in place these days. So let's face it, they're going to get into our systems and they'll attempt to encrypt or corrupt these files so that they can take control of them and hold them ransom. However, what I'm going to show you in the demo is really simple to apply, and it's transparent to the endpoint users. Typically, ransomware is delivered as an attachment to a phishing email that can bypass existing perimeter defenses. In this demo, we're going to assume that a ransomware binary has somehow penetrated the perimeter defenses such as a firewall or a web email gateway. That rogue binary is masquerading as Wordpad on the laptop. Once the CipherTrust Transparent Encryption agent is deployed on that laptop, it enables you to set up access control policies to protect folders and files. We call these guard points. On this laptop, we have one folder protected by CTE access control policies and another that is not protected by CTE. We'll see how CTE prevents the fake Wordpad from encrypting files on the protected folder, whereas the files in the unprotected folder get encrypted. Now let's go to the demo. I've created 2 directories with sensitive data in them on my desktop. One is called guarded and the other is called unguarded. You can see these at the bottom of my screen. Okay. I've also, for this particular use case, a malware app disguised as Wordpad. So here on the left, I have a compromised shortcut that looks just like the real Wordpad. I'm going to open up the real Wordpad. We'll just take a look at some of the files so you can see that they are accessible. There's the guarded file, And here's a file in the unguarded directory. Same thing with this one. And another one now in the unguarded. All right, so everything opens fine. Now I'm going to run the compromised WordPad over here on the left as a non-privileged user. The malware is going to go look for any directories called sensitive, and let's see what it does. So when I run it, it found the files in the 2 sensitive directories. It also then informs us that we've been hacked. So it's looking for files to attack or encrypt, but because we have our guard point set to the guarded directory, it fails to encrypt any of those files in there. On the unguarded directory, however, it located the 2 files and successfully encrypted those. Let's close these. We'll take a look at them again. Let's go back in here. Unguarded. Let's close this out. Go back into it. This is the unguarded file. And now let's take a look at the guarded file. It's still unaffected. All right, so if we look at the 2 files under the unguarded directory, again, they both open, and we can see that the bad guys have overwritten them with all the customer data. And again, when we looked at the guarded files, or the files under the guarded directory, we're getting access denied. So if I go in this way and go here, notice, okay, we're getting access denied. The reason why we're doing that is because the policy is preventing this particular user from accessing the directory. Why? Because this user only has access to that data when they're using Wordpad. So if I use Wordpad to go into the application as this user, you'll see that we'll be able to open them just fine. Go back again into the guarded directory. I know it's a lot of moving around, but there's no other way of showing it. You can see that we're able to open and view the data without any issue. You can also see that the files are not affected by the malware attack. Now, if we come up here and we take a look at the main screen for this particular server, we can take a look at the policy. In this particular case, we're using the ransomware demo W policy. In this policy, we can see that the data guard point is set to C data ransomware demo guarded. So this is the guarded directory, which is the one we were just looking at down here, right here. Okay. So I have a rule with an authorized application. If we go into that policy, authorized user, and I'm in there, authorized applications, I have Wordpad in there. The other neat thing that we can do is I can sign the Wordpad. Take a look at the signature. So only this particular Wordpad with this signature will work. So even if I brought another Wordpad over and it wasn't a signed version, it may not be a hacked version, but it's just not the same one as what we have on the system, or not the same binary that I had signed, it also will not work. So we can prevent this by unauthorized users. We can also prevent access by unauthorized applications. So even though the spoofed application is labeled the same and is in the same location, it is not signed and therefore is rendered useless, and your data remains safe. With modern-day ransomware attacks, the smallest compromise can grow into a disastrous breach. However, you can use CipherTrust Transparent Encryption from Talos to prevent ransomware attacks before the damage is done. CipherTrust Transparent Encryption blocks untrusted or rogue binaries from accessing the data, files, or folders using the fine-grained access controls, and protects it by encrypting your data. This means when the ransomware attack strikes, it will get denied access to the data, and if the data is exfiltrated, it'll be unusable. CipherTrust Transparent Encryption is a part of CipherTrust Data Encryption Platform. Organizations like yours can rely on CipherTrust Data Security Platform to help discover, classify, and protect your most sensitive data wherever it resides. Thank you for watching this demo. Have a great day.